Marvin as well, because he's just... Are we live now?
Hi everyone, I'm your host Stefania from BerChain, and we are giving 5 minutes for all attendees to join.
Hey, great to be here. Hi, Sylvan, nice to see you, even though you're frozen. Hey, there you are. Hi, Sylvan.
Hello, David. We're still waiting for the webinar to start.
No problem.
And our fantastic colleague Stefania is running the show today.
Yeah.
So I'll leave that to that.
Great
But great seeing you. Good to
connect
have you again.
Soon if you have a chance. I think that I've got some interesting
please, yes,
updates for you. Yeah. So.
Hi, David. Hi, Marvin.
Hi.
We are giving 3 more minutes for all attendees to join.
Cool.
Welcome, everyone.
What?
Welcome everybody to Privacy Protocols for Web 3.0 webinar. We are very happy to have all of you as joining us today. My name is Stefania and I'm BerChain Association Manager. And today is joining me also Zoe Meckbach, Polkadot Global Head Ambassador of Events. Hi, Zoe. Welcome.
Hi, guys.
So together we are going to host and moderate this online session organized by BerChain in collaboration with Phala Network. A few words about BerChain. We are a non-profit member-led organization association based in Berlin, connecting and promoting the local Berlin blockchain ecosystem. For those interested, I'll be pasting a few links on the chat during the webinar. Today's event, Privacy Protocols for Web 3.0, is an informative webinar about privacy-focused parachains in Web 3.0 and related use cases. This will be actually our closing event for this summer season. We'll be back in September as BerChain with lots of good events and news. So for today's webinar session, we will have a row of use cases presentations by today's speakers, and then a panel discussion at 6:20 moderated by Zoe. This session will be recorded and we will also have a Q&A live session at 7:10. To ask a question, please use the Q&A function in the bottom of the screen. This will allow your question to be seen by the panelists and be answered towards the end of the session. It's my pleasure now to introduce today's speakers. Marvin Tong, founder and CEO at Phala Network. Hi, Marvin.
Hi, Stefania. Thank you for the invitation. And hi, guys. We're glad to be here.
Welcome. Thank you for being here.
Thank you.
Then Joe Petrosky, Technical Integrations Lead at Web3 Foundation. Hi, Joe. Welcome.
Hi, thanks.
Thank you for being here. And then Ingo Rube, founder and CEO at Bot Labs, the company that develops also Kilt protocol. Hi, Ingo. Welcome. Ingo.
So unmuted now. Hi, Stefania. Nice to meet again.
Hi, Ingo. Thank you for being here too. And Silvani Ongerius, managing partner at TechGDPR and president of BerChain EV, participating in the panel session. Hello, Silvan. Welcome.
Hello, everyone, and thanks for joining. All right, talk to you later.
Thanks for joining. Then last but not least, we have a special guest here with us today who is going to give us an introductory keynote to open this session. It's my pleasure to welcome David Chaum, founder at XX Network. Hi, David, welcome.
Hey, it's great to be here with all of you. Some of you maybe for the first time online, but it's a pleasure. Thanks for inviting me. I guess my role here is to give a bit of a keynote, and that's it. So let me say this, that it's a pleasure to be sort of virtually in Berlin. You know, oh, hold on a second. I'm trying to get the audio, yeah.
David, if you're ready, then I'll hand the floor to you for the keynote. So thank you and welcome all.
My image is in the wrong place on the screen. I guess there's nothing to be done about that. So it's a great pleasure for me to be back in Berlin at BerChain. I enjoyed the meetups there and everything. And you know, I was in Berlin when the wall fell, actually, and I was. I'm sorry, Stefania. I see you and not me. Is there some? I'm not sure what's with that. Can we fix that? No.
David, no worries. I think it's just the Zoom, but you can go ahead if you want.
There. That's really great. Thank you for that. Okay, let me start again. Yeah, so it's a great pleasure to be here with all of you, and I'm particularly happy to be back in Berlin. You know, I was in Berlin when the wall fell, and actually I was in Berlin before that on the way to East Germany. I spent time in East Germany before the wall fell, in Dresden and so on. And I can tell you that was a life-changing experience. The difference between West Berlin and East Germany at the time was just stunning. And it's something that stays with you. The chilling effect that the surveillance apparatus there had on that society made any kind of interaction with people just very, very different. And you could just see it in the people's faces. It was incredible. And You know, in those days, it was in the West, you know, we had more or less excellent privacy because you would send letters, you know, you could meet people, you know, it was analog telephony, nothing was really, much was being recorded. You meet people in person all the time. And so you had privacy in your communication, not only what was said, but who you talked to and when. That was all off the record. There was no record of it. Whereas, you know, if you try to institute a surveillance, mass surveillance in a situation like that, it was very obvious, like in East Germany. You couldn't do it secretly. It took a massive apparatus. And so, you know, there's another important thing that happened in Berlin. The first real digital computer was built in someone's home. And this is a real engineering feat using relays. And, you know, there's a lot of, this has changed the world dramatically. But there's another piece of the puzzle that was really needed to really change the world dramatically, and that is the internet. And the internet is, to my mind, it is not just the digitalization of communication, but it is a massive engineering success to basically packetize information. To form UDP packets, they have what's called a packet routing network. And that's what was invented in 1965, and that's what dominates all global communication. It's a huge win. The guy who proposed this in 1965, Donald Davies, who I knew pretty well, proposed it as a way to have England dominate global computer technology. He said that they should build the infrastructure for packet switch network for England, and that would give them a dominant role globally in computer technology. And if they had, they probably would have had it. But now what happened was another guy also thought of the same packet switching at the same time. He's a guy who lived in his office just a few miles from my home here, where I'm talking from, and where I grew up. Also went to school at UCLA, very near their offices at the RAND Corporation. They did all kinds of fiendish stuff for the, you know, war movement during the 60s, right? As a military think tank, I believe. In any event, he wrote, oh yeah, you can do packet switching, but there's an issue of what he called traffic analysis, which is the military term for spying on who talks to whom and when, because they know that that's one of the most useful types of surveillance you can do. And when the US pulled ahead building out packet switching with the ARPA network, famously, the standards, the RFCs, you can go back and look at the one written by Steve Kent and the various versions of it, and his predecessor from the Naval Research Laboratory, they banned any kind of what I would call blinded routing. It mandated the whole design of the internet has baked into it what you might call transparent routing. It's a packet switching network. That's the old term. I guess you could just call it transparent routing. In other words, every mess, it's containerized like shipping containers, right? Every message is in a package, and I think of it as a little bus. And at the front of the bus, it says, you know, we're coming from this city and we're going to that city, and these are the stops we've made along the way. That's mandated. That's part of the rules of the road. And then when you get to like a roundabout in England, you know, then it would, you know, might come out of that roundabout in one of several directions. But back in the old days, when there was no way to really trace all this stuff, there was no worry. And even when you could imagine that someone could trace it all, the idea that someone could really analyze it and make sense of it and would care also made no sense. But now this has all been disproven and changed, because we have at the United States has admitted, and I think some other countries have, it's believed that they have a global full take surveillance capability, and they can see all the buses and read all the headers, where they're going and came from, and everything, everything. And you know, when you start to combine that with big data and you know machine learning and AI and all this, and you start to realize how much money you can make by advertising to people selectively, and then by informing them selectively and manipulating and you know dividing people up into different groups, so treat them differently. It's you know, it's had a really devastating effect on the world, and I think the public's waking up to that, has woken up to that, and so this idea of all these, you know, buses of information proudly displaying their whole path has proven to be really useful to exploit the public and make a ton of money by the people who put this all together. But what it's not, this transparent routing is not suitable for business, to make, you know, to have exchanges, to, you know, for a company, you know, they have suppliers, they have customers, they have people that work with them. All the communication with all those parties, they cannot afford for that to be known to their competitors. Look at the difference between an annual report of a company and what you could figure out if you knew everyone they talked to and when. You know, you could see all of their failed efforts and where their research and development was going and who their customers are, and everything about them, and so forth. So if in economics, markets are a key thing, and they don't work when you can see what the position everyone has is, and so forth. You know, and then when you, if participants in foreign countries and so on can collude, there's trouble. So there's really, you cannot, this transparent routing is now no longer suitable for making money, business, commerce, enterprise. And so actually, when I was at Berkeley in 1979, I read this paper by Paul Barron, and I thought, you know, there's got to be a way to stop this. And I came up with mixing. And mixing is, there's a couple different flavors, but it remains the only known way that's at all compatible with packet, you know, with routing with packet switch networks to hide from a global surveillance capability who's talking to whom and when. So that was published, you know, in 79, 82. So that was like, say, 15, 20 years after the original publication, promulgation of packet switching. And until only a few years ago, it remained kind of impractically slow, because so hop would have to do a lot of encryption. So recently I found a way to speed it up by a factor of 1,000. And that's what we built at XX Network. And it's now running on 500 nodes with a good geographic dispersion around the world. And we've processed, I think it's hundreds of billions of messages, 200 billion messages so far. You can see it on the dashboard. And so the way to think of it, when, you know, I always think of these buses when it comes to packet routing, because Donald Davies told me he loved taking bus trips around the world, you know, to see cities and stuff. So anyways, the blind routing, which is what I invented, the mixing, and we've now found a way to speed up, is you could think of it as simply like this, that there's segments of highway where there are tunnels. right? But these are multi-lane tunnels, and you're allowed to have unmarked buses. And so when a herd of unmarked buses go into a multi-lane tunnel, they can come out in a different order, a random order. And you can't see that from the satellites or from, if you're trying to surveil them. So basically, the way XX Network works is that we found a way, unlike, like when you used to come from East Germany to West Berlin, you had to wait in line for like sometimes hours. These buses now with my 1000x speed up don't get slowed down. They just go straight through those tunnels at highway speed, but they can rearrange the order. And that's really necessary for the kind of latency, the delays that people are willing to become accustomed to and are willing to accept in messaging, and also obviously for any kind of transactions, which is a lot of what blockchain in our space is about. So, we're thrilled at XX to be, part of this space and providing a better platform, a necessary platform for any kind of business activity that, or transactions, whether they're personal or company. There's a lot of, I could speak at length about the advantages to individuals of this, but I think that's relatively, goes without saying. But if you want to have a really successful decentralized world, then you can't build it on transparent routing. You have to build it on blinded routing.
Thank you, David, for this very interesting keynote.
Pleasure.
David, I also wanted to take the time from my side to thank you for joining us for this keynote and the historical insight. As the president and founder of BerChain, I wanted to make sure that we transpire that we really appreciate you joining us today and giving us this insight, not only about the historical aspects, but also about what you're working on today. So thank you so much.
It's live. I mean, we got nodes that are running. Thank you. We're very excited about that. And I would say this though, Sylvan, thanks. It's a pleasure to see you. And I look forward to the next time we get to meet in Berlin. But I have to say, watch this space. You haven't seen anything yet. Okay. If you want to wheel me in and say, okay, here's a guy who did a bunch of stuff a long time ago, and I think we're providing something really useful now with XX Network, and I think we're looking forward to being really very helpful to the whole decentralized community. Is a very important aspect, but there's more to come. We've got some other really exciting things which will change things dramatically. So yeah, I'm glad to be part of
these are very exciting times. We'll post some links for the audience in the chat, and I think with that I'll hand over back to Stefania to introduce the rest of the program. Thanks, David.
Thank you, David.
Thank you.
So now I would like to hand the floor to Marvin, who is the first presenting.
Thank you, Stefania. I'm really deep impressed by David's topic, and his idea is really inspiredful. And I will take very short minutes to share like to share the things we are doing. And can you see the presentation, guys?
Yes.
Thank you. I will be quick. Okay. It should be a 10 minutes present. I'll start with a very brief introduction about Phala Network. First, I want to give you guys like high level overview. To be brief speaking, our idea to create Phala is that we are inspired by different new trends in the technology, not for the future. I mean, from the moment. First, for now, like there's a booming data exchange between different private parties with like individuals and business, and every business-wide data proliferation of machine learning and AI, and we also know that the establishment of stricter data collection and exchange rules across the globally. And there are so many smart devices in the global network for now using by very high frequency by different people. So combine all these trends means that the world will need to exchange a lot of private user or inter-enterprise data in order to interact with its algorithm in a verifiable way while maintaining its privacy. So, but for now, like the total infrastructure is not, it's exactly not the way how it should be. So I'm not going to say like slogan or things here, but we will have the topic in our panel. But I mean, most of the services on internet for now is deployment on the cloud, but the cloud itself is very centralized into several companies like AWS, GCP, Azure, several. But to be honest, even most of the nodes of blockchain like Ethereum or proof of stake network like Polkadot also deployment in a centralized cloud service for now. So we think it's a very it's an opportunity to present more privacy to the world. So yeah, briefly speaking, Phala, we want to build not a privacy protocol, but rather than privacy preserving Web3 cloud. And another very interesting insight for us is that we think there are lots of like sharing economic in the world, like Uber, Airbnb, but cloud service, they are very, the fundamental of all cloud service is the servers, but no one sharing the servers into any cloud service. We think it's very interesting idea that using a Web3 cloud, we can build sharing economic module into the cloud service. It means that for now at the moment, people are using, developers are using AWS and maybe Alibaba Cloud, maybe GCP by IaaS or PaaS or SaaS, deployment their programs and data into the centralized cloud, and the centralized cloud, they themselves owned all the servers around the world in different data centers. But what if we can just make a P2P cloud infrastructure to the world, so that no one owns we don't own any server, but the server owners can also present a very good security and privacy preserving and availability cloud service. So, but to make that, that's why we compared with like blockchain and Web2 cloud and Web3 cloud. We think that blockchain is a very great, product to present a total decentralized and total trust-based protocol to anyone to use the Web3 infrastructure, but it also sacrifices the privacy and sacrifice the the scalability that if we need to deploy a very heavy and high performance requirement program. For now, like blockchain can barely do that, but we think there should be something like more between Web2 cloud and blockchain, which would be we call it Web3 cloud. So we think that's the next target for us to build, because thanks to Phala's many specific technical design, we can separate the consensus and the computation layer, so that it means that the computation power, the computation power can increase very scalable way. I don't mean that Ethereum is very strong, and so that Polkadot and Phala. The picture here just means the computation power. It doesn't mean anything else. But everything have like a trade-off. So to build a Web3 cloud, we separate the consensus and the computation layer. It means that we use the blockchain and TE technology to keep the security of the computations off-chain, and in this way, the computation power can increase in very high level, but it's also trustless and also permissionless, and we can believe that because even the servers are not in data centers controlled by the cloud platform. And we don't think there's any way out besides this way to create a sharing economic of computation CPU platform. But it's, of course, the whole process, the whole infrastructure is far more complicated than just two parts. So in this map, you can see that majorly there are three roles in our system: the client, the TE workers, and the gatekeepers. The TE workers are off-chain, the gatekeepers are on-chain, and the clients means like application service or the user themselves. So we built a like end-to-end encryption channel from any client inside any TE, so that besides the client and the user themselves, that nobody can encrypted data, and the secrets they are confidential, they are deploying. But why can we trust the TE workers? By some that's when we speak to separate consensus and computation. We use the gatekeepers function to manage the keys for these TE workers. Yeah, but lots of nodes and the computation power means you need to give the subsidy when the market is still not so strong. So the way we are providing the subsidy to the servers owners are that we distributing the most of our token, 80% of our token to the community and 70% of token to the TE workers, so that even we can have a very globally and very high performance and very easy to go network, even when the requirement side, the demand side is not so strong. And for the TE worker, for the server owners, it looks like a special mining, but actually it's not the same mining as Ethereum or Bitcoin, because it's not the competition is not for the target to maintain the consensus. It's more like Uber. We imagine the servers are Uber, the cars, and the drivers are the miners. So at the very beginning, we use subsidy to create a nice network for the experience. But as the demand market using the Web3 cloud more and more, we think the servers can share the profit from the whole market. So it's CPU computation mining system. So it's very environment friendly, and they don't waste electric energy at all, and it's very easy to break even for the miners. And to make that happen, we need a very balanced and solid ecosystem, token ecosystem. So that's why we got Dr. Konstantin to help us to create a game theory based economic paper based on to balance the demand and the supply, and no matter how the token price will rise and down. So of course, I will drop the token description part. It's just a utility for the token. So for now, in our testnet level, we already find like over 10 KT servers are ready to registering and providing their computation power to Phala Network. So we believe that we already covered most of the Intel SGX hardwares, and by the end of this year, we will also support AMD SEV as another major TE standard, so that the network is not relied on some certain CPU. So and we got a very strong community for now. So for now, our stage is at in the middle of a slot auction for Kusama. So we will launch our ternary network. We call it Phala Network, to launch on Kusama first, and we will see how the things going on in the real environment. And by this stage, we will also provide the confidentiality to other Polkadot application service and Parachains. And at last, I think by the before this year ends, we will also join the slot auction for Polkadot and launch our mainnet. And yeah, so and finally, this is finally the way we are going into the like the Web3 cloud service market will be we will build a cloud platform based on Phala, so that the developers who don't want to purchase token to pay the network can also have using the network, using the Web3 cloud. And but for the guys who want to directly use the network, they can deploy in their DeFi protocols or data market related applications based on Phala. So it's totally an open network to any kinds of like service or market. The first batch of use case would be a confidentiality DeFi world built by ourselves. There will be bridges for different types of long tail blockchains. There will be confidentiality swaps to provide the financial confidentiality from the MEV attacking and from the monitoring of the hackers. And we will also provide confidentiality landing to protect your position when you land some huge sites. And we will also we already like finish data mystery NFT. It means that when you want to transfer some data on chain, you can do that, but all the data encrypted, and it will appearance like an NFT. So you can purchase it, sell it, or even just to transfer it and using the metadata on chain. But the interesting part would be the really logged data can be encrypted off-chain, and it will only be controlled by the owner of this NFT. We think NFT will be the major way to exchange data. So it's very interesting. I'm not going to waste more time for you. Finally, we are also building a cloud service platform with Google Cloud together to provide more opportunities to the world. So yeah, guys, we are running a slot auction, and welcome to contribute for us if you got any case, but it's not the major topic today. So yeah, okay, so that's all. Thank you.
Thank you, Marvin, for your insightful presentation. So I'll hand the floor to Ingo.
Hi, and this time I'm even not muted, I think. Yeah, thanks. Let me share my screen as well. works. Looks like it works. Yeah, as Stefania already said, I'm Ingo. I'm from Kilt Protocol, and I would like to speak today a little bit around privacy-focused parachains and use cases that we have in the Web3 based on Kilt. So Kilt basically, so first we have to talk like 2 minutes about Kilt. What is Kilt for? Kilt basically does digital identity. And then the next question is, what is actually digital identity? And digital identity, just normal identity, consists of 2 things. It's always an identifier. An identifier in this call, Ingo would be a nice identifier for me. That doesn't say anything about my identity. It's just an identifier, right? You can call me Ingo and that's it. To create an identity, you need to add more information to that. And this is normally done with credentials. And in the digital world, that's verifiable credentials. You can think of it like your library card, your driver's license, your key to get into the apartment and stuff like that. All those are actually credentials. And they, together with your identity, they form, with your identifier, they form your digital identity. Those things are currently being standardized into different standards. One standard is called DID, Decentralized Identifiers, and one is called Verifiable Credentials. Those are standardized by the W3C, and then we are working on them in the Decentralized Identity Foundation. So when we look at how identity or digital identity worked in Web 2.0, we see it is very much platform focused. So there's the user on the left side, and then you have a huge platform that could be Google or Facebook in the middle. And basically they hold all your credentials, and they also hold your keys, which is your identifier. And when you then like to use your identity, for example, for registering with a new service, let's say WhatsApp, then WhatsApp talks to Facebook about you, but you're not even involved in this communication. So actually, this is not the nicest possible way to use identity or to represent identity, because when you look at the physical world, you basically do have all your credentials in your wallet normally, and you choose who to show them to, what purpose you show them for, and when you will show them, and if at all. So in the physical world, you have more control than in the digital world, and this is something where the internet maybe went into a really wrong direction. And what we're trying here in the Web3 is that we put the user in the center again, and the user holds her keys, and she also holds her credentials. And those credentials, the keys for one, are made by the user herself, right? So they shouldn't be made by an external entity, by a government or by a company. They should be made by the user herself. And then the user adds different credentials to that, and they are issued by different trusted entities. And then if the user meets a verifier or service in the internet, she should be able to choose if she wants to show one of her credentials, and to whom and for what purpose, and also be able to sign this with her keys to make sure that it was really from her. And we use blockchain technology, which is the Kilt blockchain, to manage those things. So now I said the user is holding her credentials and she's holding her keys. How can she do that? So, and this is where we come to an application on top of Kilt, which is one of the use cases I'd like to present. One of those use cases is definitely a new kind of wallet. We call it Sporran. And we develop it together with partners. And what the Sporran can do is very unlike any other crypto wallet. It can create accounts, it can show your balance, it can send Kilt coins. So this is where it is like a normal crypto wallet. But unlike all the other crypto wallets, it can also create DIDs, so the decentralized identifiers, so you can make your keys there and you can anchor them on the Kilt blockchain. And which is even more important, you can request, store, maintain, sign, and share verifiable credentials with the Sporran. So it's more like the physical wallet, basically, where you may have some coins in, but you also have your credentials in. You have your library card there, you have your credit card in there, you have many cards in there. And the Sporran can not only store your coins, it can also store your credentials. So going a little bit more into the real world scenarios. And another use case I would like to present is the SocialKYC. So now I think everyone knows KYC. You do this when you get to a bank and want to open an account. You also normally do that when you want to open an account with a crypto exchange or something, and no one likes it. And we looked at that and said, okay, there's obviously use cases where you need a normal KYC, but there's also use cases where you actually don't really win a lot when you make a KYC. And this is most of the internet use cases, because when for example, when I'm a gamer and I want to play a game with a person in China, I'm not really interested in his passport or where he lives. I'm interested in who he is on the internet. So I would like to know, is it really that person which has this Twitter account, or is it really this person which has this Discord account, right? So because that's much more of an identity to me than knowing where the guy lives. And if he then cheats me on the game, I'd like to write on Twitter that he's a cheater. I can't go to the Chinese government and say, hey, there's a cheater, he cheated me in the game. They probably won't do anything. So this is why we need something like an internet KYC, which is not based on anything which is in the government sphere, but more in the internet sphere. And so what's important about SocialKYC is it's sending you credentials when you prove that you are someone in one of the networks, like Twitter or whatever. And it forgets about this transaction immediately. So it's not collecting new data like a new Facebook or whatever. It is just doing the service and then forgetting about you. And the user holds the credential and no one else holds those credentials. No one else knows those credentials, and the user decides with the Kilt protocol, with the Sporran, if he wants to share that with others. So how would it work? So first of all, we have the user here on the right side. The user already has the Sporran, has some verifiable credentials, and now wants to have a SocialKYC credential. So it asks at the service SocialKYC, please can you send me, can I prove my email to you? And then SocialKYC says, yeah, you can do this. Here's a little task for you, which is basically SocialKYC is sending you an email. This has a link, and if you click the link, you have proven that you own this email account because you received the email, obviously. So you solve this little task, then SocialKYC looks at if the task was performed, and if it was performed, it can actually issue your credential. First of all, it issues a hash of the credential on the Kilt blockchain, and then it issues the credential directly to you, and the user stores it in the Sporran. The user can then look it up on the Kilt blockchain and see if it is still valid, and that's basically the use case. When the user wants to present this type of credential, then a service asks for, do you have such kind of a credential? And the user, or the Sporran, automatically looks it up if it has this kind of credential, and then sends the credential over, signed, of course, with the user's DID to the service, and the service can then look on the Kilt blockchain if this credential is actually valid, and if it is valid, it can perform what it is due to perform, right? So how does that was very theoretical. Let's for 2 minutes. Do I have 2 minutes more? I hope I do. Let's just go through this process in practice. So this is SocialKYC. This is just a website. And I choose, I want to have an email credential. So I click on email address. It opens up a little bit more. So I put my full name in here, and then I put my email address in here, and then I click on request a credential. What happens is my Sporran, which is a extension to the browser, pops up, shows me, okay, there's someone who wants to send you a credential. It would look like that. I can give it a name. I have to put in my password from the Sporran. Because I'm doing a transaction here, then it's sending me an email. Now I look up my email, and see, wow, SocialKYC sent me an email. I click on that, and then SocialKYC tells me that my email credential has been attested and saved on the blockchain, or the hash has been saved on the blockchain. And now I can save the credential. When I click on save the credential, Sporran comes up and says, just saved your credential. And now I own this. SocialKYC immediately forgets about this. Only I do have this. Of course, I probably want to save it on my hard disk or somewhere else so that my computer can get lost. That's basically the workflow. Now, if a service comes, like a newsletter service, wants to know my email address and wants to confirm that I really own this email address, you can do this in a lengthy process, or you can just click on sign up with SocialKYC, then your Sporran pops up again. Sporran selects the right credential. I have to sign it, obviously, so I can sign it with my DID, so I make sure that it's really me sending this, and I share this credential, and the process is done, right? So I'm already approved with the newsletter, because the newsletter site can look at the blockchain if this credential was real and it was issued by an attester that the website actually trusts and it's still valid, so that it makes the process a little bit easier. So who we are working with that on, many people, obviously, also from the gaming industry, because for the gaming industry that seems to be really interesting, also from biometrics, decentralized exchanges, and so on and so on. Okay, that was legal note. Yeah, okay, I can stop sharing now, I think.
Thank you, Ingo, for the presentation.
Thank you.
So we are moving forward with Joe, and this will be the last presentation before our panel.
Screen. Cool. Yeah. So I think unlike Marvin and Ingo, I don't have very many solutions to present to everybody today, but I do have problems. So I want to talk about like what the infrastructure and application development looks like as we add more and more parachains to Polkadot, and some of the assumptions that need to fundamentally change in building out this technology. So the first thing that's kind of new is cross-chain communication. It can be cross-chain message passing on Polkadot, but it could also just be bridges. And the main thing is that cross-chain messages are going to be asynchronous. So whether you're using XAMP or a bridge to another network, these messages are going to be passed asynchronously. So most applications built on blockchains make assumptions that you have synchronicity. And that kind of changes quite a lot of things, because you can kind of have, like, for example, in an Ethereum contract, you can have it fail if something goes wrong. So you can have one contract call another contract. It waits for the result. Once that contract call is successful, it comes back and continues executing its own contract. Whereas here, if you want to call something on another chain, you're going to have to finish execution of your block and then send off a message to that chain. And that message could arrive 1 or 2 or 3 blocks later. And so your block has already been finalized and it's finished. And then it's going to send some instructions to another chain, and it needs to be able to deal with that. It doesn't get to wait for the result of that. And so all the kind of like application and infrastructure development need to adapt to these new assumptions. So to make an example of a statement, statement is the first parachain that we launched. We launched the Kusama version, which is called State Mine. And that's running right now on Kusama, and it will probably be the first parachain that goes on Polkadot as well. And so this is an asset creation parachain. It uses an assets palette, can do fungible assets, and it also has a palette called uniques that can handle NFTs. So this is really basic. It just has basically balances and assets and NFTs. And this interface is kind of similar to like ERC20 for fungible assets and 721 for non-fungibles. And so you can kind of think of like, but it doesn't have any kind of like smart contracts or other advanced logic. You can just kind of create, manage, transfer these assets. But you couldn't deploy like a smart contract application to deal with these assets. You'd have to deal with them in another parachain that's either specialized for that or in a smart contract on a smart contract chain. So broadly speaking, there would be two ways to use assets from statement. One of them is that you could use a cross-chain message and just do an asset transfer. So say you want to use some assets like USDT or something from statement and you want to use it on Phala or Kilt, you could send a cross-chain message and just make a transfer from statements to those other parachains, and then just use those assets synchronously, kind of with the same assumptions that you're used to dealing with. And so this still kind of treats you do this one-time asynchronous call where you send the transfer from statement to this other parachain, but then you kind of deal with them in like the isolation of your own parachain. And that kind of lets you do development under your normal assumptions, but you do make a lot of efficiency trade-offs, and you violate this like don't repeat yourself principle of programming. And the reason that you're making these trade-offs is really that like you're representing the same thing in multiple places. So if you think about having like 100 or 200 parachains, you have this one parachain statement that specializes in asset representation. So it represents, it stores, it makes state changes very efficiently to assets. It doesn't have any kind of like gas metering, so it can do these transactions very fast, efficiently. Why would you copy that over to a smart contract parachain and use gas and all these other inefficiencies in something that's not specialized in representing assets? So now you've represented the same thing maybe 100 different times with 100 different levels of efficiency, just so that you can still develop using your same mental model of having synchronous execution. So another way that you could use statement is to actually just leave all the assets in statement. So you could have like a smart contract on another parachain with an application, and you just kind of tell this contract, hey, there's this other parachain out there. It's called statements. You don't really need to know much about it except that it exists and it has these assets on it. And these account holders who are involved in this smart contract also have accounts on statements, and be able to execute that smart contract and calculate the side effects. So you might do this, run this application, and after processing your block, you figure out, okay, we need to make these 5 balance transfers of assets on statements, and we can just send that in a cross-chain message. So a cross-chain message with a batch of transfers to statements. That message could arrive 1 or 2 blocks later. So you don't really get to see the results of those transactions while you're executing your transaction. Your block has already been finalized and it's finished. So it's a much more efficient way to use a parachain because it keeps just one thing represented in one place with specialized logic, and takes advantage of this cross-chain messaging. But you lose this environment of synchronicity, and you need to kind of design the application around that. And this just requires a complete redesign. You can't just like copy and paste your application from some other platform onto this. You need to kind of rethink your assumptions and how you deal with this. So moving from like applications into infrastructure, we're like statement isn't going to be the only parachain. There's going to be a lot of parachains, not just like ecosystem chains, but these common good parachains. And like as we move logic outside of the relay chain, so we want to have like a staking parachain or a governance parachain and move all the transactions outside of the relay chain so that validators can focus on just validating parachains. I've talked about this in like other presentations and only have a few minutes here. But you can think about like one address in Polkadot. It could have like context in a lot of different parachains. So it could hold some KSM or DOT on statement. It could be running, it could be staking and nominating or validating on a staking parachain. It could be a council member on the governance parachain, or maybe it voted for counselors, or it's voted on a referendum. And it could be like the contract owner manager on like a smart contract parachain. And so this one address can have like balances and roles and privileges on several chains. And so you can't really think about like an address on a chain. It's really an address in a network. And there's all these different parachains that a backend of an application or user interface might have to connect to. And so if you're designing like a wallet, which is kind of like the most basic piece of infrastructure, how do you kind of reason about having all of these different chains, and how should you react to user asset or user actions? So like on statements, you have to put down a deposit of 1 KSM or 100 DOT to be able to mint an asset. And so if this UI sees that, hey, you have 50 DOT statement and you want to create an asset, but maybe you have more, maybe you have 200 DOT on the staking parachain. Can this UI kind of handle, well, first I have to send this cross-chain message to get some DOT from staking into statement and mint this asset, and actually show you kind of like a holistic view of this address's role in the entire network. And finally, tooling to help people like kind of actually reason about these systems. If you have like a very simple question, like, well, I made this transaction, what happened? If you're dealing with a single blockchain, this is easy. So you can go to example for Etherscan and say you used some application on Ethereum, and you can just kind of like click on the hash of that transaction, and you go to the page, and it just shows you, here's a list of kind of like all the things that happened when you executed that contract. When you introduce asynchronous messaging, this becomes much more difficult, because if you say like, well, I made a transaction on Kilt, what happened? It could be a lot of things. There are things that happen directly on Kilt as a result of that message, but it also could have triggered a batch of outgoing messages to other parachains. And you'd also want to look at the execution results of those messages which are on other blockchains and also other block heights. So it's not like you can just say, hey, this happened in block 1001. It could have happened in block 1001 on Kilt and 2005 on another chain, and whatnot. So you have like these kind of like second order effects, and maybe those chains actually send cross-chain messages as a result of those transactions that got sent to them. And so this actually becomes a much more complicated issue, and a lot of the infrastructure providers, they can't just run like an archive node to one chain. They actually have to run nodes to a bunch of these chains and figure out how to make sense of the data that's going on between them. So I hope that I stayed within my 10 minutes, and that was my whole presentation.
Thank you, Joe, for your presentation, and thank you to all the other speakers as well that presented. Now I think we can move on with our panel discussion moderated by Zoe.
Great, yeah, thanks, Stefania. Let me take over from here, and I will welcome, first of all, a warm welcome also from my side again to the event. And we have all the three speakers or presenter on the panel, as well as Silvan. He was introduced by Stefania in the beginning. So welcome back, everyone. Just wanted to say that it's a very cool round in this panel discussion, because I mean, Joe, Ingo, and Marvin, you guys know each other from the Polkadot ecosystem. We have talked a lot about Polkadot throughout the presentations, and Silvan, it's very great to have you on board as well, because I'm interested in also your points of views to some of the questions, having you as also a consultant on tech GDPR. So yeah, looking forward to the panel and all the coming questions and your answers. Great. Yeah, let's jump in. I would like to open the panel discussion with the more of a personal question, actually, to all of you. My question is, what does privacy actually mean to you on a personal level, but also on a level in the working environment? I mean, all the missions and divisions that you're working on currently. And let's start with Silvan, as we have not heard him yet today.
Thank you so much. Yeah, great question. So for me personally, I think privacy is more than anything else protection against information imbalance, right? So if you look at there are so many large corporations and governments and everything around there, and as a private person, it's very difficult to protect yourself against these kind of entities. They know a lot about you and about a lot of people, and you actually hardly even know who's the owner of the company, right? Who are the shareholders? This is very difficult to figure out. And I think in this particular case, it is very good to have your right to privacy and to be able to protect yourself against these kind of information imbalances. So I think that's for me the more personal aspect to it. For the working environment, quite clearly, I work in privacy. We consult organizations on how to build better products for privacy and to meet the regulatory requirements under the GDPR, etc. So that's my bread and butter, so to say.
Great, thanks, Silvan. Marvin, would love to hear your point of view on this.
Yeah, thank you, Zoe. It's a good question. For my personally, I think privacy is like the reason why we doing this startup technology company and to building a Phala network, and because after I graduated, I worked in internet companies for years, and during this period, I see that how these companies are using people's data to capitalism for high efficiency strategy or better user experience, but most of the time like selling to earn more profit. So this is why I think at last I think it's a terrible situation. I have to say it's a terrible situation for now on internet for people's privacy. People don't actually have the real privacy except in some crypto hacks. And there's another story that I used to write a report to explore the situation happened in data dark market in dark night. And after the report have a really high focus and attention to the audience. I'm personally being attacked by these hackers to explore my personal privacy to the world. And so so for me, I hate this kind of thing. But for the work, I mean, I used to use the data to do analyzing and strategy, for example, machine learning, such as things. But after a while, I'm born of that, and I think we need to build a new things up. And that's one we saw again with Dr. Gavin's, his blog about the version of Web3. I think that he described a better world than now. So we want to fight for it. So that's why we are aiming and target on privacy all the time. We think it's really important. Like it's not a special feature. It's just the right thing to do. Thank you.
Great, thanks, Marvin. Also very inspiring to see that you had, your own personal experience, how it should not work, and this, of course, inspires you and motivates you to build something in the space. Very cool. Joe, let us know your experience.
Yeah, I think you're right. Like, it is a very personal question because it is something that's different to everybody, and so, in my opinion, it comes down to control, really, of like having control over your information and what you share. Some people are very happy to share lots of information kind of broadly, or lots of information with specific parties. And some information you kind of have to share. So if you think like medical information, you have to share those with your doctor, but you don't want to broadcast it to everybody, maybe. And so I think it really the meaning of privacy is kind of like understanding what you're entering into. So like if you use some website or you buy something online, to understand who actually sees that information, how they're able to use it, and to have kind of control over what you share and with whom. So I think it's kind of a concise answer, but that's it's very personal. So it really comes down to like control and transparency about how your information is used and in what circles.
Yeah, no, I love this answer, Joe, because you said something very important, that people have to be aware who they're sharing the data with also, right? Some people are more open to share more data, but maybe they also don't know exactly what's being done with the data. So that's why I think, I'm always a promoter of education, and I think it's very important to also explain more what actually is being done with data currently on platforms like Instagram, Facebook, and so on. That's why we are on this event, and we are in the space building, right, in Web3. But I think it's very important also to educate on this topic. Thanks for sharing this. Ingo, how about your experience?
Yes, so first of all, everything that was said until now is completely correct. I don't want to repeat it, but maybe I can add something. I think we need a right to be anonymous. because this is something that hasn't been thought of a lot probably in the digital world. When we look like 100 years back also, to 150, then telephone and postal services basically came up, and there were laws about how you actually stay anonymous. The government is not allowed to look into your mail, right? Depending on which part of the world you live in, obviously. But we see now in the digital world with things like WikiLeaks and the and other whistleblowers, we see that it's actually really, really important to have technology which allows you to stay anonymous while communicating. This is completely independent of which part of the world you live in. Because as a whistleblower, you can still be prosecuted in Western democracies. So we shouldn't look in arrogance to other countries, actually, where it is maybe even more dangerous. But in the end, when you look at all the cases from Julian Assange and all those, it is basically dangerous everywhere to communicate disclosed information, and it should be a right for us to stay anonymous in communication, and this is what also is a part of everything around blockchain, not specifically Web3 what we're building here, but I think cryptography and also what we heard in the first speech in the keynote is also a part of that. So we always have to build technologies which allow the people to actually exercise their right to stay anonymous and to communicate in a secure way.
Good, thank you, Ingo. Yes, and very important to know, I mean, privacy is really a global topic, right? It's not connected to anyone, any specific country. Everyone on the world has actually the right for data privacy. Great, so let's jump a bit into the infrastructure or infrastructure level also. And since you're all, you guys specifically working building privacy protocols in the Web3 space, I would like to know a bit what kind of tools and even services do you or would you like to see a bit more to actually build privacy protocols or also your products faster? And in this connection also, maybe are there some tools or even concepts in the current Web 2, right, that can be translated or can be used also in the Web 3? Maybe Marvin, you want to start with this question?
Thank you, Zoe. I will make a quick start. Like, for example, I think Brave is a good sample. You know, like although Brave browser is not as totally encryption way to protect people's privacy, but it make a big step from like Chrome or other browser. So it's a good sample, and it also proves that privacy preserving products can be used in good user experience. You don't need to abandon lots of habits on using things. But in another case, I think for deployment or developers, there are still many of tools or stacks haven't have a Web3 version or haven't have a privacy preserving version. For example, I think when we are speaking to a database, the major Web3 database for now, the protocol is basically based on IPFS protocol, Filecoin, Where, and other storage protocols. But there's no database standard for encryption data on-chain. And so that's like computation and other cloud service, even CDN. So I think for developers, there are still many of things need to be filled in for the Web 2 to Web 3 gap. We are also doing that for the computation part. So yeah, I think that covered the answer. Thank you, Zoe.
Thanks, Marvin. Joe, maybe your perspective. You've presented some topics in the presentation, but I would love to hear your point of view. Oh, we can't. Yeah, now we hear you.
Yeah, I think I presented more questions than answers. So I don't know what I can contribute, but I think actually like a lot of tools exist already. They just need to be moved into like a better user experience, similar to what Marvin said. So we still rely a lot on like full node or archive node providers in order to like interact with blockchains and whatnot. And so we're seeing like an increasing push towards light clients and being able to like run things in your browser, or like having a light client as a browser extension or something, so that you can verify this data. And you can kind of like extend this principle just from blockchain into everything else that has like very like server and client heavy models. Like the more that you can do on the client side and to actually like verify and not even transmit certain data, the better it is. And so like we have a lot of good tools. Like, I mean, even WhatsApp, as much as we can hate on Facebook and whatnot, but, you know, has end-to-end messaging, but still, you know, by the fact that this one company is running all these servers, they can still cut people off from communicating. They still have the metadata about who's communicating with whom and when and where they are. And so there's a lot of tools there, but like as you can shift more of this stuff from like centrally hosted like node providers or databases or clouds into more like locally hosted verification tools, where you don't need to push so much information through a central provider, but can actually kind of have all this like more anonymous or encrypted data as centrally hosted things, and more verification and processing happening on the client side. Like, yeah, I would just say like globally, like the move should be to push this processing like towards the edges and not from the center.
Great, thanks, Ro. This is a very good insight. Just wanted to remind all the attendees that you guys can ask questions in the question and answer box. Because after the panel, we also open up to a Q&A session. So if some questions are coming up throughout the panel, please use the box for this. Okay, let's move into a bit of regulations, right? Data laws, very important for our big topic in data privacy. How you actually how are you complying with such data regulations, right? So I would like to ask Ingo, did you had any, or what maybe where, or did you had challenges when actually developing your product to be GDPR? I mean, in Germany it's GDPR, in the United States you have the CCPA regulation, to be compliant with such regulations.
Well, it's we are actually moving in the same direction as the GDPR, because what GDPR actually tries is to somehow make the big companies treat your data in a way that is a little bit more sincere. So if my data is at company X, I can with GDPR ask company X to delete the data, basically. So this is the idea behind that, and that was the goal was obviously that that people care a little bit more about their data, and we have the same goal. We just have a little bit of a different approach. We say, hey, why does company X have to store your data in the first place? Actually, you can share it whenever it's needed, right? So so we're moving in the same direction. So we're not anti-GDPR or something. It's basically, I think it's maybe not the, it's the right direction, but maybe the wrong approach. So which kind of problems do we have with that? So as we don't store data or personal data on the blockchain, we don't have a problem. Then there could be a potential problem because GDPR was made in 2010, I think, or 2012. And by that time, blockchains were not known. So blockchains are not written down there in the way, and they're not treated in any way. So I think we need to revise that. And I think this is ongoing right now, and make blockchain and cryptography things possible in GDPR. So one of the things that's wrong in GDPR, I would say, is that they treat hashes of personal data as personal data, which actually, well, if you look at it like a mathematician, there should be something like, if it is hashed in this way, at least then it's not personal data anymore, because you can't retrieve it. Because when if you take the data and you encrypt it, then it's not personal data anymore, which doesn't make sense. So there's things which have to be changed, and they will be changed. But I'm pretty positive, because there's a lot of intelligent people we're talking there to. So it's again just going to happen, and so I don't see any problems right now.
Great. No, this is a very good insight, especially like how you compared it. I mean, sometimes there's some, it's very clear. I mean, you said you only store hashes on the blockchain, which is the preferable way, right? You should never put original data on the blockchain, but sometimes you have connectors, right? That you can connect the hash to original data. And that's why sometimes there are some regulators saying, okay, you should not be even able to have or to actually connect this type of data. But you said there are a lot of intelligent people talking about it. I would like to ask Sylvan also, as you consult on this topic, what are some of your advices, or maybe when you want to share also from your experience, how you consult startups, I guess, also companies in the blockchain space to be compliant with such regulations, or maybe also some challenges you sometimes see the startups going through.
Right. No, I agree. Perhaps not with everything, but with a lot of what Ingo said previously. I think there's a lot of visionary alignment, right, between what people are trying to do in this space, build better products for privacy, and the GDPR is in essence also trying to build a more private society, I'd say. So there's visionary alignment. But then, if you look at the nitty-gritty details, there are certainly some difficulties around hashes, around data deletion, but I think the biggest one that I see is around the specific roles. The GDPR is very specific about who is actually the controller or in charge of the data and who is only processing data, the processor on behalf of those entities. And this, more than anything else, is in my experience, the big issue in decentralized environments. If you look at GDPR application, who in a network of nodes that all have kind of like equal rights in a public permissionless network, who is actually in charge of that data, who's responsible? And for regulators, that's also increasingly difficult to figure out, as we're not only talking about just blockchains anymore, but about parachains and everything that is attached to the latest developments. So these areas are specifically difficult. Now, of course, the first thing that we look at when we're working with clients is like what kind of personal data are you actually processing? Do you need to process that? And first and foremost, do you really need to have such things on chain? Many blockchain enthusiasts like, yeah, we can fix this with blockchain, we can solve that with blockchain. But the first key thing to look at is like, do we actually need to have personal data on chain, even in the form of hashes? How much can we detach it from it? And can we still build the same functionality while better guaranteeing privacy? At the same time, if you take decentralization a step further, that is, of course, if you instead of have a centralized data storage, decentralize more things also around personal data, you achieve a couple of things with it. First of all, you don't have the central entities anymore that sit on heaps of data, but you also create much less interesting targets for potential attacks, right? So if you don't have all the data in one place but spread it out over a decentralized network, that brings many advantages. Again, visionary alignment, but the implementation is difficult. And I think I'll stop there because I've been talking about it for a bit.
No, that's great. I mean, you're all expert on it, so always good to hear you talking on all these questions. Okay, so thanks for the insights on this. Let's talk a bit about other privacy tools. Zero knowledge proofs is also a way actually to secure privacy, right, on the blockchain. We have in the Ethereum network, for example, the adoption quite, I would say fast of zero knowledge. We have the ZK snarks, for example, and even older technologies such as mixers are available. And I just want to ask you guys, since we talked about the Polkadot network, but we can also talk about more in a general way, how you see it. But I would like to start actually on the Polkadot network, how you see it adopting in the Polkadot ecosystem. I know I think we have not implemented zero knowledge proofs yet. I know that also the research on Web3 Foundation is on it, but maybe you guys can give some insight and also your personal view, how you actually see it even benefiting the network. Maybe Marvin, you want to start with this?
Cool. It's a very technical question. I will try my best. So I think ZK knowledge is the most elegant way to encryption transactions and information between each other. So, but of course, by some projects are already using it for the crypto transfer, but for the more complicated logic program like a smart contract, there's it's really hard, So that's why technology like zk-SNARK came out to deal with the more complicated programs for to encrypt the whole data processing into a end-to-end encryption. But zk-SNARK have limited use cases to target. It's the best practice to target on the problems of quadratic arithmetic programs. We call them QAP, I guess. So it's like if you know some certain diagram and you can encrypt it in another way. It's pretty similar with goblet circuit. So I think it's a more it already helped the whole industry to explore more opportunities on privacy, more simple logic. But for generalized computation and generalized programs, which we are using every day in our service and applications, it can't be still have problems in widely used scalability, because let me put a very simple example. If there are many looping in programs, right? It's always looping the same string, but in this case, in internet programming is very generalized, but in zk-SNARK, it will increase the whole size of the probe in a very crazy level. So it means that zk-SNARK is very good trial, and it's help the industry in another level, but it will have some problem in certain more generalized computation tasks. But yeah, I think I think for on-chain use case like DeFi or layer 2, zk-SNARK and zk-related technology is still the best practice. But for some certain use case and more complicated, like data related or how to say more complicated programs like technologies like T or PC fit the use case more. So I mean, different tools, different technology tools fit for different types of use cases. Just don't too upsetting on some certain technology. It's a cut. Thank you.
Great, thanks, Marvin. Anyone else want to add something to this question? Okay, let me jump into a next one. Also looking to at the time of the event. So let's maybe wrap it up with the last question to all of the panelists. I mean, you're working on great use cases and products also, focusing on privacy in the Web3 world. What are more use cases or even final products that you would like to see outside of the ones that you are actually building in the Web3 world? Joe, let us know from your perspective.
That's the hardest question. Yeah, I guess applications are tough because it's very far away from kind of what we tend to deal with on day to day. So Polkadot is very low level and it's kind of meant to deal completely in abstractions. So, we don't even really process blockchain applications. It's just an arbitrary state transition function. And we see a block header in the Polkadot relay chain, and that's it. So when you kind of add in the parachains and tooling and application development and user interfaces on top of that, it's very far away. I guess what I would like to see is more like holistic approaches to like developing on multiple chains, and also not just in blockchain. So like in one dimension, people think of like blockchain applications as applications whose logic lives on a blockchain. But I think there's actually a lot you can do across that, where like if you think of these blockchains as having specialized applications like an identity platform on Kilt and computation on Phala, and maybe like a payments chain somewhere else, you could build an application where you log in with your identity from Kilt and make a payment with some other blockchain. And this kind of replaces the like, log in with Facebook, pay with PayPal type of buttons that you would see. And so you'd actually have an application that whose backend is entirely built on blockchains, but it doesn't actually have any logic itself on a blockchain. So I think this kind of like approach to application development and architecture is one big shift that could happen. So I can't really name like a specific application. I'll be really excited to see when like an application comes out that is actually architected in this manner. And the other thing that's like kind of goes beyond blockchain, and it's kind of maybe an add-on to what Marvin was saying, is that privacy on blockchain is just one layer of like multiple layers. So if you ever try to like do something anonymously online, it's really hard because like there might be like the email address and like login password that you use. There's your IP address. There's the networking. There's all these like things in your computer, like your browser dimensions and pixels and stuff that kind of like identify this as being a common device across multiple actions. So there is no magic bullet like ZK Snarks for something that just solves privacy. And I think like the more tools that people have to have like a good user experience that does actually address like a lot of the different layers in one time and uses a lot of different technologies in one application and architects it with privacy as one of the principles on which it's built. I think that will be like a really interesting development.
Great points. Thanks, Joe. Silvan, what is your point of view on this question?
Yeah, I definitely agree on that, and I think more fundamentally what we see is that there's this whole concept around privacy is a little bit opposite to trust, right? Not always, not per se, but in general. So if you don't know who someone is, how can you trust them? And I think blockchain or decentralized environments really enable that, and that is what we need to make better use of. The whole idea that basically, and I'm just looking at Bitcoin, Ethereum, these kind of things where most people get their first kind of touch point with blockchain is all behind KYC walls. You need to go to an exchange, identify yourself, and actually that is something where first of all, it throws up hurdles for adoption. Secondly, it is in many cases not really necessary. Like I don't need to identify myself to get 10 euros from my colleague in cash, right? So why do I need to do this on exchanges? And the whole idea is that, yeah, sure, we need to protect ourselves against money laundering and terrorist financing, but it's a bit over the top here. And I think this is one of the big hurdles, and we need to find solutions to that. And one of the things that I think is like, what if we can find alternatives to the current KYC? Think about SocialKYC. Like if 100 people can trust me, then perhaps I don't need a governance kind of verification, which is in general good for my privacy. I can still be trustworthy without revealing my personal data. So things in that direction, zero knowledge proof is something that can be very helpful. I think there are a couple of points, but we need to rethink a little bit what we're doing on the, identifying ourselves for every little thing that's really irrelevant. I think we can be more anonymous about many of the things that we do online, in particular in Web 3.0.
True, very true. And I mean, there's always the now I don't know the English word, but spagat, between like the security, and of course we're talking more about the data privacy, but also the usability, right? And I think we are very much in the beginning to see, okay, how can we make it actually very secure, and then provide the data privacy, but make it very usable for the user. That's a big challenge currently. We are all working on this. in the space. So I'm looking forward to see what's coming out. Ingo, your last words on this question.
Okay, this last word, I tried to put together zero knowledge proofs and applications and blockchains and try to in one answer. What is really neglected a little bit sometimes, especially when is the sharing of data. Because when I share data, I always copy it, right? And if we want to have privacy and data autonomy and all that, that's always nice if I have my data for myself and then I select who I share it with, that's cool. But then I share it and then I shared it and then the other guy can basically at least read it more than once and maybe misuses and stuff like that. And I think this is where we need applications as well, because there's many things that we share and copy all the time. So it's think of copyrights, right? So if you download a picture, or if you just look at a picture in your browser, you already copied it to your hard disk, right? So you already stole it somehow, and it will be possible for you to misuse it in a way. So there's many things we have to look at, and this is a lot of that is on application level. We need more applications. We need applications that allow us to actually watch things without copying them, which is a huge endeavor. And zero knowledge is probably the first step that we need to do this. So if I, as an application, need to know that you're 18, I don't really need to know how old you are, right? So I can send you basically a small application which you execute using your credentials, checking on the blockchain if it's valid, and then just sending the information back, yes, it's over 18, right? So those kinds of applications are definitely needed, and there's a huge world of things that we have to build, or many other people also have to help us. We can't build them all. And I think for really going into a Web3 world where we have real data privacy, there is so many things to do, and a lot of them have to do with zero knowledge proofs, obviously, but there needs to be also other ideas probably.
Definitely. Beautiful. Thanks, Ingo, for your input on this question. And Marvin, what's your point of view in like what privacy-focused use case or more products and tools that you would like to see?
Yeah, I think I will make it brief. I think guys already make a very good opinion for this, and in my personal view, I am pretty worried about what happened in the Web2 world now. Like the use cases and how they use the data are like only increasing, more crazy and more crazy. So because of the AI, so the value inside this data are increasing. By the way, so just to look at what happened in California in last century, when people found some place have gold inside, they will like try their everything they can to mint them out. So that's the data. So I think I'm more expecting that like data related tools will happen on a Web3 world, and it can build a shield inside a Web2 world. But for now, I think the besides the financial use cases, for now, like the crypto world haven't provide such data related tools to real make the real revolution of Web2 development. But I think the Web3 network will create such thing. Maybe it's Kilt, maybe it's Phala, maybe it's Polkadot. So we don't know, but it will there will be there. So I'm expecting this maybe in 1 year or 2 years, and the world will see like besides financial revolution, crypto can also bring the data revolution into the real world. So that's also what I'm expecting for. Thank you, Zoe.
Thanks, Marvin. Great. And therewith, I would like to close also this panel. Thank you to all the panelists. And yeah, it was great to have this insight for you. I'm very excited to see what we are continuing to build in the space, specifically bringing more privacy to the users. And yeah, therewith, I will give over to Stefania.
So thank you so much, Zoe. We reached our webinar end time with no questions so far from the public. So I guess we can end this session here. So again, thank you so much, Zoe, for the great moderation, and thanks to all the speakers who have participated and gave us all their insights. And thank you to all attendees who have joined. I wish you a nice summer, and we'll see you back in September.
Bye-bye. Thank you.
Thanks, everyone.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Bye-bye.